So let's go ahead and bring those conditional probability ideas to a story with random variables and calculate some conditional means and variances. So the random variable in the example that we're going to use this lesson in the next few is the, we're going to call it x, random variable x is the location of median voter on city council post-election. Okay, so the election is going to be the source of uncertainty here. And using that spatial model that we talked about briefly in the last lesson, we're going to assume that the city council has 3 members, okay, and that they are arrayed on this left, right dimension like this. Person A is the farthest to the left, and then B is to her right, and person C is to the right of both of them. And we are going to put numbers on these ideal points. So we're just going to say that person A's ideal point is a 0, person B's is a 1, and person C's is a 4. Okay, so just looking at this model, currently B is the median voter. If we're going to ask ourselves, where do we think the policies coming out of the city council should be? They should be pretty close to 1. All right, so there's this election. And to kind of keep the model simple, we're going to assume that these guys have staggered terms. And so only member A is running for re-election. B and C will run in different years. Okay, so A is running, and A's opponent is A prime. Oops. Yeah. Correct what I accidentally erased there. Bring back all the rest of my dimension. And A prime is way over here, even to person C's, right? A prime's ideal point is 5. Okay, so that's where the uncertainty comes from. And with that, we can start to draw out the little table that defines the values for random variable x. Okay, so x will either be 1. Okay, that's what will happen if A wins the re-election. The median voter will still be B because it'll be A, B, and C. Let's write that over here. This is if A wins. Or X, the location of the median voter, will be 4 if A loses. So now we don't have A anymore. Once again, I didn't really want to exit out there, but I guess I am here. And then the new council would be person B, person C, and person A prime. And so if A loses the election and is replaced by A prime, now C is the median voter here. So if A prime defeats A. Okay. So starting to define this random variable, and we're getting a sense of what's driving the uncertainty. But as I said, I wanted to add the idea of conditional probability here. And the way we're going to do it is we're going to say, well, what's going on with this election? It depends on how the voters are feeling. Okay, the election probabilities are different if the voters are kind of riled up, they're mad at incumbents. I'm going to call that if there's an anti-incumbent sentiment, than if they're not. Okay, so we're going to have 2 columns of probabilities that correspond to these 2 possible worlds that we're in. Okay, so one possibility, we're looking at the probabilities that X is either 1 or 4, conditional on this event, and I'm calling AI, anti-incumbent sentiment. Okay. And to just make some numbers that seem reasonable. If there's anti-incumbent sentiment, that's bad for A's re-election. So let's say that there's a 0.3 probability that A is re-elected in that situation, and therefore 0.7 probability that A fails. And then there's the other world. We're going to do the probabilities of X given that there's not anti-incumbent sentiment, kind of just normal politics, maybe not a whole lot of salience to city council elections, maybe name recognition helps the incumbents in this world. Again, just making up some numbers here to flesh out the example. The probability that X is reelected, that A is reelected, and that X takes the value 1 is 0.8, and therefore the probability that A loses is replaced by A prime, and the median voter shifts to the right is just 0.2. Okay, so all we've done here is add the conditional probability to a model where our events are numbers, just exactly as we were doing in the past unit. And what this means now is that we can calculate means and variances using either this set of probabilities or that set of probabilities. So we can calculate the expected value of X conditional on AI, okay? And that would be 1 times 0.3 plus 4 times 0.7, that is 3.1, or we can calculate the expected value of X conditional on no anti-incumbent sentiment. And to do that, we're using, of course, the same outcomes here. The conditional conditioning events are not affecting the values associated with the outcomes. They're just giving us a different set of probabilities. And so in that world, the probability that X is 1 is 0.8, and the probability that X is a 4 is 0.2, and that is 1.6. Okay, so these are our conditional expected values, or as we tend to say, conditional means. Okay? Expected value conditional on one event, conditional on another event. Okay. We can do the same thing with variances. And since I want to be able to look at these same numbers, I hope it doesn't bother you too much if I erase some of the stuff at the top of the page here. That's redundant at this point, just to give myself a little more good space to work with to calculate the conditional variances. Okay, so the variance of X conditional on AI. Let's just remind ourselves what a variance is. It's the expected value of X squared, but now it's the expected value of X squared conditional on AI minus the expected value of X conditional on AI, that whole thing squared. And okay, so what is that? It's expected value of X squared conditional on AI. So again, I'm using this set of numbers. It's 1 squared is 1, so 1 times 0.3 plus 4 squared is 16. 16 times 0.7 minus the expectation squared. Okay, nice. I calculated the expected value of X conditional on AI down here. So that's what I'm squaring. 3.1 squared. This is more than I can do in my head, but when I plugged it out on my calculator, I got 1.89 here. And we can do the same thing, conditional on null anti-incumbent sentiment. So let's maybe clean up a little bit more space here. We're done with that. To calculate that other conditional variance. And so same deal. It's I guess I'll go ahead and write out the formula anyway, just to really drive this home. It's the expectation of X squared conditional on no anti-incumbent sentiment, because that's what we're conditioning on here, minus the conditional mean squared. And what is that? Just as we did before, now we're keeping the outcomes. They don't change, but now we're taking the probabilities from the no anti-incumbent sentiment column here. So expectation of x squared, well, 1 squared is still 1. That is happening now with probability 0.8. And 4 squared is still 16. Yes, it is. And now that is happening with probability 0.2. So there's my conditional expectation of x squared. Expected value of x squared conditional on no anti-incumbent sentiment. And I'm subtracting from that the conditional mean, that number squared. So again, I found that here. Here's my expectation of x conditional on no anti-incumbent sentiment. It's 1.6. 6 squared. And again, punching that out just on a calculator here, I get 1.44. So, and the interpretation of these, I think, is just, kind of obvious. If we're in the world of anti-incumbent sentiment, of there being anti-incumbent sentiment, the expected value of the median voter is 3.1. It's pretty far to the right because of that anti-incumbent sentiment, and the variance is 1.89. If we're in the world of no anti-incumbent sentiment, our expected value is smaller. We think the city council is more likely to be to the left, and there's a little bit less variance associated with that. Okay. So as one of the reasons why conditional probability is so useful is that it's the way we tend to naturally think about things. So the kind of the idea that the variance is one thing if the world is this way, and another thing if it's that way, is almost always something that we just kind of naturally want to say. We can also build up an unconditional model from a conditional probability model. We did this before when we were talking about random variables. Well, let's just go ahead and do that here. So now the question that we're asking is, say we don't know whether there's an anti-incumbent sentiment or not. What do we think the expected value in variance would be? Okay, so before I go to another page, let me just give you the preview of what it is. So when we did this before, we used the law of total probability. If we know the probabilities that are conditional on an event and the probabilities that are conditional on a complementary event, all we need to know is the probability of the conditioning event. And we plug all that stuff into the law of total probability and find the unconditional probabilities. That is exactly what we're going to do. That's so sort of a theme you're going to be seeing over and over again when we're changing what we're conditioning on, going from conditional to unconditional. What we're doing is changing the probabilities associated with random variables, and we're changing them just in all the ways that we learned about in Unit 2. But we're just simply applying those probabilities now to random variables and calculating expected values and variances. Okay, so to go to the next page here, what we want now is the distribution of x. X is still going to take values 1 and 4, but now we want the unconditional probability here. Okay, and so as I said, we're going to use the law of total probability. So thinking about what I want to put right here, the probability that x equals 1, let's just think over on this side of the board, the probability that x equals 1 is equal to the probability that x equals 1 in a world of anti-incumbent sentiment times the probability that we are in that world, plus the probability that x equals 1 conditional on being in the world where there's no anti-incumbent sentiment times the probability that we're in the world of no anti-incumbent sentiment. Okay, and so that is indeed the law of total probability. Okay, so remembering what we had before, the probability that, in fact, I think I'll just keep writing over here. The probability that X equaled 1 in the world of anti-incumbent sentiment, remember that was 0.3, okay? And the probability, leaving a space for the probability of their being anti-incumbent sentiment, the probability that X equals 1 in the other world was 0.8. Let's assume that we're just sort of like maximally uncertain here. The probability that there is anti-incumbent sentiment is just as high as the probability that there's none. So that's kind of implying that probability of anti-incumbent sentiment is 0.5. Okay. So put that here is 0.5. Tells us that the probability that X equals 1 overall is 0.55. So that is my answer. I'll put it over here. The unconditional probability. Before we know whether there is anti-incumbent sentiment or not, or just in the world that we don't know, because maybe we'll never even really find that out. That's the probability. And we could either do the same thing for the probability that X equals 4 here, or we could just subtract 0.55 from 1, and that's what I'm going to do. And then we calculate the unconditional expected value and variance just the way we always have. Okay, so the fact that we built up these probabilities from a conditional probability model doesn't really affect how we calculate unconditional means and variances. They're just probabilities. So we do it the way that we always do. So the unconditional expected value of X is 1 times 0.55 plus 4 times 0.45, and that equals 2.35. And same deal with the variance. Let's just kind of keep going here just for the fun of it. The unconditional variance of X is the unconditional expectation of X squared minus the unconditional of expectation of X squared. That is 1 times 1 is 1 times 0.55 plus 4 times 4 is 16 times 0.45. That's my expectation of X squared here. And subtracting off from that, my thing I just found, the expected value, that number squared here. What do I get? I get 2.25. Okay, and so it might be kind of interesting to compare the numbers we got for unconditional mean and variance to what we had before. So let me do a different color. Let's do purple here. Compare that to expected value of X when there was anti-incumbent sentiment was 3.1. Expected value of X when there was no anti-incumbent sentiment was 1.6. Okay, that's it's always going to be true. The unconditional mean will be in between the conditional means. So before we know whether we're going to be in the world that's likely to lead to a more right-wing council or preserve the left or a relatively left-wing council, our expectation of where the council is going to be in between those two things. Or maybe another way to think about it is think about kind of a sequence. Before we know whether there's anti-incumbent sentiment or not, we're thinking of the probability that X wins is 0.5, 0.45 that they lose. The expected location of the median voter is at 2.35. But then if we do some surveying or some focus groups, whatever we're doing here, and we figure out, wow, there's really anti-incumbent sentiment this year, that would increase our forecast about the post-election location of the median voter, move it to the right. If we found out that there was none, it would move it toward the left. And comparing the unconditional variance right here to the conditional variances. What did we have here? The variance conditional on there being anti-incumbent sentiment was 1.89, and the variance conditional on there being no anti-incumbent sentiment was 1.44. And what we see here is if we compare the conditional variances to the unconditional variance is higher, okay? So finding out whether there's anti-incumbent sentiment or no anti-incumbent sentiment reduces our uncertainty in both cases. That kind of makes sense. It's not always true, but in this case, in many cases, it is. Okay, so that was all pretty straightforward. It's kind of not what we're typically doing, though. What's still atypical in this little example here is that the thing that we are conditioning on here is an event, this anti-incumbent sentiment or not. Random variables are so useful that we almost always use them all the time. So where we're going in the next 2 lessons is to be thinking about conditioning the value of conditioning one random variable on the value of another one. Okay, so asking questions, if we observe, say, the location of the median voter on another voting body, does that tell us something about X? So for that, I'll see you in the next video.